Now we'll look at graphing parabolas with the vertices that are not at the origin. So the following is a summary of the standard, again from the book. Standard features the parabola with a vertex at point hk. So it's not at 0, 0. So if you have an axis of symmetry, which is y equals k, then you have this form here, which y minus k squared equals 4p times x minus h. The focus is h plus p, comma k. The directrix is h minus p, and your endpoints of the lattice rectum are going to be h plus p, comma k plus or minus 2p. For the axis of symmetry being x equals h, you would have this form here, x minus h squared equals 4p times y minus k, then the focus is h, comma k plus p. Directrix is y equals k minus p. And your endpoints of the lattice rectum are going to be h plus or minus 2p, comma k plus p. And here's an example, some imagery. So if your p is positive, again, opening to the right, negative opening to the left. This is if you have the y as a squared term. And if you have y, the x is the squared term, y is the linear term, you would have this either opening up or down, opens up if p is positive, down if p is negative. You can always pause that and study that some more. So how to graph it. So determine which of the standard forms applies to the given situation. Is it the y squared or the x squared part? Use the standard form identified in step 1 to determine the vertex, axis of symmetry, focus, equation of the directrix, and endpoints of the lattice rectum. If the equation is in the form y minus k squared equals 4p times x minus h, then use the given equation to identify h and k for the vertex hk. Use the value of k to determine the axis of symmetry, y equals k. Set 4p equal to the coefficient of x minus h in the given equation to solve for p. If p is greater than 0, the parabola opens right. If it's less than 0, it opens left. Use hk and p to find the coordinates of the focus. Use h and p to find the equation of the directrix. Use hk and p to find the endpoints of the lattice rectum. Now if it's the x part is squared, then use the given equation to identify hk for the vertex. Use the value of h to determine the axis of symmetry. Set 4p equal to the coefficient of y minus k in the given equation. Solve for p. If p is positive, it opens up. Negative opens down. Use h and k and p to find the coordinates of the focus, and use k and p to find the equation of the directrix. Use h and k and p to find the endpoints of the lattice rectum, as you see here. So plot the vertex, axis of symmetry, focus, directrix, and lattice rectum, and draw a smooth curve. So we have y minus 1 squared equals negative 16 times x plus 3. So we're going to label the vertex, axis of symmetry, focus, directrix, and the endpoints of the lattice rectum. Okay, so we have the standard form is y minus k squared equals 4p times x minus h, right? So that means our h is negative 3 and the k is 1. So our vertex is going to be at negative 3, 1. And 4p equals negative 16, so p must be negative 4. That tells us something right there. It's going to open horizontally because the y part's squared, and to the left because p is negative. So let me come down and start putting some things in here. So negative 3, 1 is our vertex. Negative 4 is p, so that means our focus is going to be 1, 2, 3, 4 over here. So our focus is going to be negative 3 minus 4, or plus negative 4, comma, 1. So that's going to be at negative 7, 1. Our directrix, it's going to be x equals excuse me, -3 minus -4, so x equals 1. Matrix x equals 1. I guess I should label the axis of symmetry. And that's at y equals 1, the k-coordinate. Okay, and then we have to find the endpoints of lattice rectum. So 2 times -4 is -8. So we're going to take that focus. Focus is here. This is the vertex. Okay, take the focus, which is at -7, 1. And so lattice rectum is going to be at -7, 1 plus 8. And that's going to -7, 9. And then -7, 1 minus 8, or -7, -7. So that's going to go, so it's -7, 9. I think this goes to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9's here. Oh, it needs to be over here. Sorry. And then -7, -7. So 1, 2, 3, 4, 5, 6, 7. And then I think we have all the parts. So it's going to be a curve like this. And more like that. Okay. So this is, let me note. I told it to change colors. Okay, that's it. That was kind of fun. Okay, let's do example 5. Graph x squared minus 8x minus 28y minus 208 equals 0. So we have to solve this and put this in the right format. So let's get the x terms on one side. X squared minus 8x. I'm going to move the minus 28y and the minus 208 to the other side. So equals 28y plus 208. Now I want to complete the square. We have x squared minus 8x plus -4 squared. So I did -8 divided by 2 is -4. That's what I did here. And then so I'm adding that there. I have to add it to the other side as well. Plus 208 plus -4 squared, which is of course 16. So this is x minus 4 squared equals 28y plus, so 208 plus, that's 16, should be 224. And I can factor out 28 from both these terms. So I'm going to have x minus 4 squared equals 28 times y plus 8. So that means our vertex is going to be at 4, -8. And we have 4p equals 28, so p must be 7. Okay, now if we were to graph this, let me see here. Our vertex is 4, -8. So 4, negative 8. 1, 2, 3, 4, 5, 6. Let me rescale this because I just seeing that P as being 7. I mean, we're looking at, so focus is going to be at 4 comma negative 8 plus 7. So that's going to be at 4 comma negative 1. That's not a problem. What is a problem is the width. So we're going to have a problem getting too far out there. So our lattice rectum is going to be at 4 plus 2 times 7 comma negative 8. That's going to be 4 comma, no, sorry, that's 18 negative 8. And then it's at 4 minus 2 times 7, negative 8. So that means it's at negative 10, negative 8. So we have to graph those. Our directrix, by the way, is going to be at y equals negative 8 minus 7, so y equals negative 15. So I'm thinking I should scale things by 2s on this. So let's see. I said 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. I go negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. That's probably far enough. And I'll do vertically as well. So we'll do negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16, negative 18, negative 20, negative 22. Is that going to capture it? Yes, it will. Okay, so let's go ahead and plot some points. We have a vertex we said was at negative 4, negative 8. Why is it not scrolling? Okay, sorry about that. Negative 4, sorry, positive 4, negative 8. We have a focus at positive 4, negative 1. I have to draw through that, so let me erase that. We have the directrix at negative 15. Okay. What else do we need to have? Lattice rectum is going to go through the focus, so it is at, oh, this should be at negative 1. Okay, because it goes to the focus, not through the vertex. So negative 1, 8, 18, 18, negative 1, excuse me, and negative 10, negative 1. So and then I'm going to go to green and do the axis of symmetry. It's just going to be x equals 4. Okay, I think we have what we need to graph it now. Okay. And did I label everything? Vertex is at negative 4. Sorry, positive 4, negative 8. Focus is at 4, negative 1. Okay, I think that's everything. There we go.